So let me get started with saying a little bit about myself. So I'm Yemi. I'm a junior at the University of Texas at Dallas, and I'm majoring in molecular biology. And I took organic chemistry last semester, which was interesting because we were taking it in class at first, and then we transferred to online, which I had to switch up the way I learned things because now we were watching it on video instead of being in class and asking questions. But yeah, so let's get started. So I'm going to be sharing. I'll be using basically the PowerPoint that my teacher used last semester because it was really good, especially like for intro to organic chemistry. So yeah. So first with organic chemistry. So basically what organic chemistry is, it's basically studying a bunch of compounds that are made with carbon. So basically any compound that you study will be, or it'll have a carbon, or it'll have something to do with carbon. So why we actually learn organic chemistry, it's really good for us who are majoring in biology or things like that, or planning on going to medical school, or things like that, especially because it teaches us this non-linear thinking, and it helps with our critical thinking. And majority of it is it'll be using the periodic trends that we learned in general chemistry before, and basically transferring it to the structures and the reactivity of these compounds. So basically majority of organic chemistry will be using these molecules and compounds and teaching us how to see how they will react in different situations. So like when you go towards the end of organic chemistry 1 and into organic chemistry 2, it'll basically be all reactions. So I want to tell a little bit about the tips I use for studying organic chemistry. So majority of it'll depend on how your lecturer will give you the tests and things, but majority of it is really just practice and practicing over and over with different things. And that's why these sessions, like at first, will be a bit shorter, but then as we get into the school year and people are starting to learn things, then we'll start doing more practices, and if needed we can have study groups. So yeah, and there's also Khan Academy that you can use, and there are also tutoring groups in your school, but I think learning it from somebody who just went through it would be also beneficial, which is why I'm here, and I dedicated this time to teaching you all about this and tutoring. Yeah, so this is basically saying all that I just said. And yeah, I went into this. What is organic chemistry? It's just studying carbon compounds. And these are, some uses of organic chemistry in real life and also in the lab, how we'd use it, like using an ammonium cyanate and using heat will turn it into urea and things like that. And these are some more compounds in real life. And over the course of this semester, you will learn how to, make these just by, reading the name, or by seeing the structure, you'll know how to name it. And this is also carbon. So this is the first instant that we are seeing what we learned in general chemistry into organic chemistry. So what is really important here is remembering that carbon makes 4 bonds. So no matter how you put it, no matter how you draw it, it'll always be 4 bonds. So there are various topics that will transfer over into here and the good thing that I like about organic chemistry is that it's not really math-based like general chemistry is. It's more images and drawing molecules and reactions. So that's kind of nice if you weren't really too good with math. So yeah, some of the topics from general chemistry that you'll need to remember is like what we have here first, valence electrons. We'll also be going into orbital structure and energy, Lewis dot structures, and the Hund's rule, orbital configurations. But the good thing also about organic chemistry is that you only see a certain amount of elements. You won't be seeing like the whole periodic table. So that is really good also. But I'll be going into that more later. And yeah, we'll also be looking at the octet rule too. And if we have time today, we might build some molecules and practice with that. So starting with valence electrons. So we know that we can see the amount of valence or electrons based on what group the atom is in. So we see carbon has, because it's in group 4, it has 4 valence electrons. And these are going to be more important later on when you're building molecules because you'll know how many vacant spots there are and how many atoms it can attach to. So with orbital structure and energy, you don't really go into this a lot in organic chemistry 1, but it's more prevalent in organic chemistry 2. So I won't really touch on this, but as it comes up later on, we will touch more on this. So yes, so here's the list of atoms that I was saying that we are going to be focusing mostly on in organic chemistry. And as you see, it's just pretty much almost the top row, the top section of the periodic table. And you know, that's really good because then you can just basically memorize how many valence electrons they each have. So when you're creating bonds, it'll be much easier. So with the Lewis dot structures, we remember that because of how many valence electrons, that's how many little atoms we're gonna dots we're gonna show on each atom. So we can see this on hydrogen, carbon, and nitrogen, oxygen, and fluorine. But yeah, obviously we know because of the Hund's rule, there's a particular way we have to draw each and every carbon, each and every atom per se. Like you can't just put it on this side or just do it like this. It has to be balanced and put in a particular way. And if I'm going too fast or I need to slow down or you have a question, you can just unmute your mic and ask. So let's get to building a molecule. So when you're building a molecule at first, we know that with Lewis dot structures and with valence electrons, you have to remember how many valence electrons each atom has so you can know how to connect each one. So we know carbon has four valence electrons. So I will just put And we know hydrogen has 1. And with the 4 next to it, it was supposed to be a subscript 4, but obviously she didn't know how to place it like that. But yeah, so it'd be a subscript, and how it would be written is like this. So yeah, so because we have 4 hydrogens, we would basically put them in where there's an empty spot with each carbon, with each electron on carbon. And because the hydrogen brings another electron, we would just put it right here. Because now the hydrogen and the carbon are sharing electrons, so they can have a full orbital. So yeah. So who wants to try the next one?
For the CH3, would it be like the carbons have like a double bond together? Or no, just one bond, and then on their sides are the H's?
Yes. So let me try it out. Oh. Yes, so that's how we would draw it for this molecule. But as we go on and as the molecules get bigger and bigger, as we can see here, drawing all these little atoms gets more harder and harder, and it gets, a bit confusing. So what we do in organic chemistry is, instead of drawing out 2 electrons, we use just 1 line. And for that, this is how it would look like if we're doing it on this first molecule. So that's how it would look. So does anyone want to try drawing the second one in the way we would do it for organic chemistry?
Would it just be the same where all the like 2 dots are? You would just replace it with a line?
Yes. Would you like to draw it first?
How do we do that on here?
You go to the top and it should allow you, it should have all these different tools and you just pick the draw tool.
Oh, okay.
Great. Karina, do you want to try drawing one molecule?
I'm on my phone, so I don't know if it like.
Okay,
I
you
don't
can
know
just
if it
tell
will.
me how you would draw it and I'll draw it for you.
Okay, so for the like third one on the first row,
Mhm.
so you would connect all the C's, right? Or is that not
Yes.
right?
Yes, yes. Oh, but another thing I needed to mention, if there's a molecule or some atoms in a parentheses, that will be connected directly to the atom in front of it. So instead of just connecting all the C's, we would connect the N
Oh, okay.
and then the C would be connected. And because it has the 2 in the back, there'd be another one on this side.
Got it.
So then, yes, all the H's would come off of this. Okay. So since this is our first session, I don't want to go too much into the long and complex one because there's another trick for that. So I want to practice more with drawing these bonds. So Okay, so let me put some examples down. Okay, so I'm going to draw the first one and then you guys can try the rest. So with CH2CH2, we know that it's one carbon, it's two carbons with two hydrogens coming off of it. So when you're drawing it, usually you connect the biggest, the ones with the most valence electrons to each other, just because that's how they'll mostly be connecting in any example that you come across. So it'll be that. And then we do the two hydrogens coming off from each other. But when you look at this molecule, it's obvious that carbon hasn't fulfilled all of its, it doesn't have a full orbital. So to satisfy that, that's when we can use the double bond. So just go like that. And that shows the two lines in the middle shows that there's 4 electrons connecting the 2 carbons. So who would like to try the next one?
I can try it.
Okay.
So would I connect the C and the O together?
Yes.
I don't know if this would be correct.
You
I
were
know.
so close when you drew it before.
Oh, okay.
So since the H comes right after
We
the,
would put it with the C.
yes.
Okay.
But the only thing with, you did great. You did a great job. Thank you. But the only thing is with oxygen, you need 6 valence electrons. So because of that, we would use 2 little dots on both sides to
Oh yeah, I
signify.
completely forgot about that.
It's fine. But you just have to remember that because that does come up a lot of times with the C connected to the O, and you have to remember to put those 2 groups of electrons on. So yeah, thank you. So do you want to try the next one, Karina?
Yeah, so that'll be a triple bond between the carbons and then like having the hydrogens off of them, right?
Yes. Great. And I will try this last one, and I think that will wrap it up for today because I just wanted to do a little intro. So for this one, the carbon would connect first. And a trick with this is to build the molecule like you're reading a book. So make sure you're connecting the first atom to the next one and then to the next one. But usually if there's a hydrogen, it'll just connect to the carbons, and then the carbon will connect to the next biggest molecule. So then we'd have the 2 hydrogens coming off, and then the nitrogen and the other nitrogen. And obviously this does not satisfy this carbon, so it would become a double bond and a double bond here. But nitrogen needs 5 valence electrons. So this one has 4, so we would just put 1 here. And this one needs 3. Oh wait, I drew this molecule wrong. I was like, why does it look weird? But it was supposed to be CH2NH. So, okay. So in that case, we would still have the double bond, but there would be just 2 valence electrons instead of just the single one, and then the H will connect. And usually that's how nitrogen will appear. Usually it'll just have always have the 2 little electrons on the top. So do you guys have any questions?
So on this last one that you just did, how come the hydrogen connects to the nitrogen and not the carbon?
Well, in this example, because the hydrogen comes after the nitrogen, it'll connect to that instead of the carbon. If it was like CH3N, then the hydrogens would connect to the carbon.
Oh, okay, got it. Thank you.
You're welcome. So any other questions? Well, if that is all, then I will round up this session. It was lovely having you girls here, and I will see you guys next week.
Thank you so much,
you.
Yami.
You're welcome.
Take care.
You too.
Oh, and then are these sessions like recorded and are they going to be like put onto the Discord server?
Yes, I will record it, and it's currently being recorded, and I will upload it later.
Okay.
And I'll
Thank you
post it
so
in.
much.
You're welcome.